Hello students, welcome to class 12 physics. In this video we are going to discuss about the topic potential due to an electric dipole. In previous lecture we have studied about the electric potential energy and electric potential. So let us once again revise what is electric potential energy. The work done by the external force in bringing a charge from infinite distance to a point within the electric field, that is called as electric potential energy. And electric potential, that is work done by the external force against the electric field in bringing a unit positive charge from infinity to a point in the electric field, that is called as electric potential. We have studied about the electric potential due to a point charge. Now here we are going to study about the electric potential due to dipole. And we know what is dipole. Dipole is the two equal and opposite charges separated by finite distance. So first of all, let us draw the dipole. Here we are having plus Q charge, minus Q charge. It is separated by a distance 2a. Let this point be A, let this point be B. Let the midpoint be O, and due to this dipole we are going to find the electric potential at point P. So over here let us consider this point P. So we will be finding the potential at point P due to the plus Q charge. Potential at P due to minus Q charge, and here from the midpoint to point O, let it be some distance R. So first of all, consider a dipole having charges plus Q and minus Q separated by distance 2a. As already said that whenever we need to write the theory, first of all we need to know what we are going to find, and we need to first discuss the figure. So here what we are going to find? We are going to find the potential at this point P due to the electric dipole. So first we need to define what is dipole. Here we have seen in the figure we are having a dipole having charges plus Q and minus Q separated by distance 2a. Here the midpoint of the dipole, that is placed at the origin O. Let midpoint of the dipole is at origin O. Now what we can see over here, the distance from plus Q charge to this point P, that is R1. So let us define that. Here R1 equals to distance from plus Q to point P. Now you can see over here from minus Q charge to this point P, distance is R2. So R2 is distance from minus q to. Now what you can see from this midpoint of the dipole to point P, you are having distance r. So r equals to distance from midpoint of dipole to point P. So this we have discussed about the figure. Now what we need to find, we need to determine the potential at point P. So what we are going to do over here, to find the potential at point P due to these two charges, first we will be finding the potential at point P due to individual charge, that we have already studied, the electric potential due to the point charge. So first we will be finding the potential at P due to plus q charge, then potential at P due to minus q charge. So here potential at P due to plus q charge, that will be what? Let us consider that as V1. Potential at P due to plus q charge. That is, what is the general equation for the electric potential? That is V equals to kq upon R. So that will be K, here charge we are having plus q, upon distance between the point where we need to find the potential and the charge, that is from P to plus q, we are having distance R1. So writing that, so what it will be? It will be V1 equals to kq upon R1. In the same way, we will be finding potential at P due to this minus q charge. Potential at P due to minus q charge. Let us consider that as V2. Again writing the general formula kq upon R. So here K, charge we are having minus q upon distance between this potential point P and this minus q charge, that is R2. So that will be R2. That is V2 equals to minus kq upon R2. Now we need to find the total potential at this point due to plus q charge and minus q charge. We have got the individual potential due to the plus q charge, potential due to the minus q charge. Now on applying the superposition principle, we get the total potential at that point due to the dipole or due to both the charges. So total potential at P, let it be P equals to V1 plus V2. Here V1 is what? kq upon R1. So that is kq upon R1 plus V2 is minus kq upon R2. Minus kq upon R2. So that will be what? V equals to, let kq be common. Here we are having 1 upon R1 from the first term, plus minus minus, and 1 upon R2 in the second term. So this is the total potential at P due to both the charges. But over here we need to find this 1 upon R1 and 1 upon R2 term, and then we will be applying the formula for that in this equation. So let this be equation 1. Now see, from this point plus q charge, let us draw a perpendicular line on OP. Let this angle be theta, and let the point over here be named as point N. Why we are drawing this? Because see, here this R1 Here it is having point A, AN perpendicular to OP, and here AON equals to theta. Angle AON equals to theta. So from triangle AON we can write cos theta is equals to adjacent upon hypotenuse, that is ON upon OA. What is OM? Here see, we are having here R1 distance, here the total OP is R. So when you take the perpendicular bisector, this OM will be what? That will be R minus R1. Also OM equals to R minus R. So it is R minus R1 upon OA distance. Here O is what? That is midpoint of the dipole. So you can consider these distances A, as well as from O to B this distance is also A. So OA distance, that is A. Now taking A over here, let it be R minus R1 equals to A into cos theta. What we need? Here we need to get 1 upon R1. So first of all, taking R1 as the subject, here it is minus R1, so take this term on the right hand side and take this term on the left hand side. So that will be what? R minus A cos theta equals to R1, or R1 equals to R minus A cos theta. Now we need to take the reciprocal of this, but before that let us take R common from this. Taking R common over here, here the first term becomes 1 minus second term becomes A cos theta upon R. Now taking reciprocal of this, taking reciprocal, what we get? On the left hand side it will be 1 upon R1 equals to this term, it becomes 1 upon R, and here we are having power 1, so we can write 1 minus A cos theta upon R raised to minus 1. Now see, here we are having the negative power of this term. So these terms can be solved by using the binomial theorem. So first of all, write down up to here, then we will be solving the further steps. Now as I said that the second term is having the negative power, so it should be solved with the help of the binomial theorem. So first of all, let us write the general formula for the binomial theorem, that is x plus 1 raised to minus n is equals to 1 minus nx plus 1 by 2 factorial n into n plus 1 x square plus 1 by 3 factorial n into n plus 1 n plus 2 x cube and so on. Right? Here we are having the x term is minus a cos theta by r and plus 1. So instead of x, what I am having? Minus a cos theta by r. Minus a cos theta by r plus 1. Here instead of n I am having 1. minus 1. You can write here n equals to 1. Now applying this formula over here, the first term is 1 minus n is 1. X is what? Here you are having x, here you are having minus a cos theta by r. So that will be minus a cos theta by r. Plus second term, that is 1 by 2 factorial, and that is 1 n plus 1, that is 1 plus 1, 2 x, that is minus a cos theta by r whole square. And let us not solve the further terms. Why? Because see, here it will be 1, here minus minus plus a cos theta by r. Here what we are having? 2 factorial. 2 factorial, that means 2 into 1, that is 2. So 2 gets cancelled. Here we are having squaring of that is a square cos square theta upon r square. Now see, here in the third term, we are having r square in the denominator. Now from the figure, this r distance is very much greater compared to this distance a, because as I have already said, the P point is very much far away from the dipole. So this distance a from the midpoint of the dipole to the charge, that distance is very much smaller compared to this r. As r is very much greater than a, r square will be infinity. So these term can be considered as 0. So neglecting a square by r square term. So what we are having? This minus a cos theta by r plus 1 raised to minus 1 equals to 1 plus a cos theta by r, or 1 minus a cos theta, again rearranging this by r, raised to minus 1 equals to 1 plus a cos theta by r. So this is what we are getting for 1 minus a cos theta by r raised to minus 1. So first of all, you note down this, and that we will be putting this term, we will be replacing the formula for this over here in this equation. Now, writing this equation for 1 upon r, that is equals to 1 by r. What we got? For 1 minus a cos theta by r raised to minus 1, it is 1 plus a cos theta by r. Now, what we need to find? We got this 1 upon r1 value. Now here we need to find for 1 upon r2. For that, what we will be doing? We will be taking a perpendicular line. We will be drawing a perpendicular line from this point O on the line BP. And here, these angle will also be theta. Let us consider this as point N. Now let ON perpendicular to BP and OBP, angle OBP equals to theta. Now see, as already said, these three lines, these three distances are parallel to each other. So when you take the perpendicular line on this point, the distance between these two, that is VN, will be R2 minus R. R2 minus R. Therefore, from triangle OBN, here it is N, from triangle OBN, we can write cos theta equals to adjacent, that is BN upon hypotenuse, that is OB. BN upon OB. That is BN is what? R2 minus R. And OB, that is what? That is distance A. Taking A over here, what we get? R2 minus R equals to A cos theta. We need to get 1 upon R2. So first of all, taking R2 as subject, taking minus R over here, so that will be R plus A cos theta. Taking R common over here, from this term, R common, so first term becomes 1, plus in the second term it will be A cos theta by R. Now what we need to do? We need to take the reciprocal of that. Taking reciprocal, what we can write? On the left hand side it will be 1 upon R2 equals to, on the right hand side it will be 1 upon R. Reciprocal of this becomes 1 plus A cos theta by R raised to minus 1. Now again when we apply the binomial theorem for these terms, by binomial theorem, by R raised to minus 1, that will be 1 minus A cos theta by R. See, if you want to remember it in a very simple way, what you need to do? Whenever you are having a negative power, right? Leave first term as it is. In the second term, you need to just multiply this power, right? So here the first term as it is plus the power, that is minus 1. So multiply the power with the second term. Minus 1 into A cos theta by R, that becomes minus A cos theta by R. Here also you can see what I just said. You have to just multiply this power with the second term. First term as it is 1 minus, multiply this second this power with the second term. So minus 1 into A cos theta by R. So minus minus becomes plus A cos theta by R. So what we have got? 1 plus A cos theta by R. So whenever you got the negative power and when you want to apply the binomial theorem, just remember like this. Okay. So we got by the binomial theorem, the second term is 1 minus A cos theta by R. So now these equations can be written as 1 upon R2 equals to 1 upon R into 1 minus A cos theta by R. We got this equation. 1 upon R1, 1 upon R2. We need to apply over here. V equals to KQ into 1 upon R1 minus 1 upon R2. So now equals to KQ 1 upon R1 minus 1 upon R2. That KQB answer is 1 upon R1, that is what? 1 by R into 1 plus A cos theta by R minus, what is 1 upon R2? That is 1 upon R 1 minus A cos theta by R. Now from both these terms 1 upon R can be taken as common. So KQ by R, what it will be? 1 plus A cos theta by R minus 1 minus A cos theta by R. plus a cos theta by r minus 1 minus minus plus a cos theta by r. Here minus 1 plus 1 gets cancelled. Here a cos theta by r plus a cos theta by r, that becomes twice a cos theta by r. So that is kq by r. Twice a cos theta by r. So now you can rearrange this. K 2a q cos theta in denominator r into r, that is r square. And here 2aq is nothing but the dipole moment. We know what is dipole moment, that is the product of the magnitude of the charge and distance between the two charges, that is 2a. So instead of that, can I write p cos theta by r square, because 2aq is equals to p. Now here we are having k p cos theta by r square. So writing that in the form of dot product, I can write k p vector dot r cap upon r square. So this is the potential at point P due to the electric dipole. As you can see over here, p vector that is the dipole moment and its direction is always from negative charge to the positive charge. So this is the direction of p vector. Here r cap, that is what? It is the unit vector along OP distance. Okay. Now as you can see when we are talking about the potential, that is what? Potential due to a point charge, that is V equals to kq by r, right? That means potential due to a point charge, it varies with 1 upon r. Here what we are getting? Potential due to the electric dipole, that is k p cos theta upon r square. In the denominator what we are having? We are having square of the distance. So potential due to the electric dipole, that varies with 1 upon r square. So students, you may note down this here.